Guys, so you've got a DC fault on your PV system, and let's talk you through it from start to finish to see if we can find out exactly what is going off. My name's Justin. I am an independent consultant and I work in the solar industry here in the UK. And if anything in this video is useful, like it, share it, pass it on to a team that might find it useful. So we're going to go from the inverter side of things all the way up onto the roof, talking through each little section that we're going to go through and some of the common places that we can find faults in those systems. So the first thing that we come across is the MC4s. Now, treat every wire in this system like it's live. Treat every wire like it's going to bite you. Treat every wire like it's got a fault on it, that it's going to fall to bits in your hands. Be super careful in this environment. So we've gone to our inverter and we've obviously got a string down. So we've got one of those DC cables is not working. So we're going to look at the MC4s. We're not touching them directly. We're going to run our hand close to see if there's any thermal effects coming off that MC4s, to see if there's something crazy going off on the inside. Don't touch them because they might be absolutely red hot, stinking hot. Thermal imaging comes into play in certain environments. This is one that it could be useful. Should we be signing it off on test sheets? That's down to the guys at the IET and the guys on the NIC board. Be interesting to see what comes through their regulations over the next few years when we get more than 5% of our roof space is filled with our good solar. So we're being very careful. We've turned our ears on. We're listening for arcs and sparks crackling. We've turned our smell on. We want to know, is it smelling a burn? Is it smelling a fish? Is there a smell coming from the inverter itself? So we know we've got a string down because we can either see it on the monitoring or we can see it on the screen, and we're tracing it from here. Is there a DC isolator on the inverter? This is a common one. Oh, my system's not working. The last guy left it off when he tested it 6 months ago. You turn it on, suddenly they've got half the power back on again. Common mistake in systems is not having a checklist to follow to make sure you're doing systematic checks. So we've checked the MC4s. Now we're going to check the cable from there to the isolator. Now, some people run their fingers down it. Some people run their eyes down it. Some people put their clamp-on ammeter on it. I'm saying look at it first, trace it through. You're looking for nicks, you're looking for bends, you're looking for insulation showing, you're looking for somebody putting black tape around that black cable to try and hide where they've scored it when they've dragged it through the roof too fast. We're looking for any form of heat damage on that cable. So we're tracing that through, following it all the way through into the isolator. We want to make sure that it's identified as well. So if it's one neggy on there, it wants to be one neggy there. If it's two posi there, it wants to be two posi there. The clip-on identification is great. The tape identification is okay. We just want to make sure that we know exactly what we're tracing out here, because you don't want to be following one cable when it was one of the other ones that's down. So you follow that into your isolator. We're obviously going to check the rating on that isolator every time we come to an isolator. Every time we come to a DC isolator, let's check its rating. Is it 1000? Is it 900? Does it need doubling down? Does it need doubling back on itself? Does it need the weird little plastic thing shoved in it so that it actually goes to the rating that it says it's going to be at? So we've looked in there, got our testers on it, treating everything like it's live, and we've got our DC probe testers. We've gone through all the sequence, still not got any power. We're still checking for thermal effects. We've still got our nose turned on, because sometimes when we open it, it stinks. Sometimes as soon as we move the front off it, suddenly water can pour out of the bottom of it. If it's outside, then it can get a little bit moisture in there as well. So now we're going to trace the cables from the top of there all the way up onto the roof. Before we move on for here, if we've left it out of the inverter and we've still got it in our isolator, and we are isolated on the roof, we're in a position where we can test and measure the short length between the isolator and the inverter. This then enables us to know 100% that cable's good, or 100% that cable's bad, and we can whip it out and change it while it's there. Remember to use your MC4 crimp tool, don't use your pliers, and remember to use your ferrule crimps in the isolator so that you're getting that good solid correction in there. And some people, most Sparkies, are using Newton torque screwdrivers to make sure that they're within the parameter of that isolator. So we've got our DC coming from our inverter, connected up, looking good, marked up, going into our isolator, marked up, looking good, nice and tight, little bit of extra left in the isolator, so if we have to re-terminate for some reason because we've gone into the wrong one, all good. Now, still not got power there and it's going up onto our roof. We've now got quite a task of going, right, we're going to have to follow this cable, we're going to have to trace it with our eyes, trace it with our fingers, trace it with whatever we can get our hands on. We can also test it with our testers. We can do a continuity test, we can do an insulation resistance test. Obviously, we don't want to blow the snot out of our panels on the roof, and we don't want to cause any problems for anybody else potentially working on the system if that line is down and that's going to a roof fabric. We don't want to be zapping somebody somewhere else on the system or damaging something that is plugged in or somewhat in another part of the installation. So we're going to trace that all the way up to the roof. We get up onto the roof and we're testing now the cables between the roof and the isolator. A drawing would help right now, wouldn't it? And we're checking there to see if we've got continuity and a good insulation resistance test, making sure that those cables, as they've been brought through the fabric of the building, that they haven't twisted together and managed to burn holes in between each other, as well as if moisture's got in there or bugs have got in there and just had a good nibble at it. It wasn't long ago since pulling cables under floors in council houses as an apprentice, and you'd see a whole nibble line all the way down the cables. I'm pretty sure that is going to start happening in DC world as well, which is not good for our kit when it's not been installed to the correct standards in a commercial and an industrial environment. So now you're on the roof, now you've got up there safely, and you're testing to see, have I got good voltage coming off my panels, and have I got good insulation and continuity going back down to my inverter. We're then going to go and slowly unplug one panel at a time, and we can check them one at a time, or we can check a string, we can check groups of them at a time, and that's going to then systematically break it down into the different steps. In short, with DC testing, let's make sure that we've got a good continuity front to back and we've got a good insulation resistance front to back, making sure that we're not getting them muddled up with anybody else. A really good way to do this is to have a method of connecting up and testing when you come to power up your system. So in part of the commissioning phase, which we'll do a later video on, if you've got a rhythm, a pattern, a checklist that you always follow with your team, it's so much easier when you're coming up against these types of problems of a misconnection or a lost connection within the system. And another little tip that helps us out in commercial world is we'll do an array map. If we've got 20 panels on roof 1, 25 panels on roof 2, and 3 rows of 30 going all the way across the roof, we'll mark that out on a drawing, colour it in a different colour, laminate that and leave it by the fuse board. Because who knows, in 20-25 years time, when those panels are still absolutely fine, somebody may be rewiring it, or vice versa. The panels may have died out and somebody needs to be able to read and understand and make it safe. Save us stripping out whole systems just because of one cable going down. Helps us keep inverters on when one cable goes down or one isolator goes down. Let's hope that you guys in the industry are working thorough and quickly and safely out there. That's Justin, and hopefully I've brought some knowledge and some wisdom to the DC testing side of a solar installation.